Hi everyone, I'm Leo Traeger from UMBC, and in this video I'm going to demonstrate our interactive data management platform Scoper, in which users can explore and navigate through a pulley store by streamlining heterogeneous schemas into linkable subsets for matching. With open data, organizations can improve decision-making by integrating external data. For example, one organization is interested in matching similar tables and attributes from selected collaborators, repositories from their cloud vendor, or external marketplaces. This results in a pulley store with highly heterogeneous schemas and an exponential search space of linkages. For a human, verifying all linkages becomes extremely time-consuming. Even with matching methods, the global parameters for filtering false linkages are not only unknown ahead of time, but they vary from schema to schema. Notice how the matching complexity reduces when we remove all the unlinkable schema elements. We aim to solve this problem with collaborative scoping, a recent method that we proposed for this exact task, in which we make use of language transformers and self-supervised autoencoders for outlier detection. I will now present the demo. The user enters Scoper's web platform and can preload 4 different matching scenarios on related schemas. In order to show the effectiveness of reducing irrelevant schema elements, we extend both scenarios with one entirely unrelated schema on Formula 1. Of course, the user can also import their own set of schemas. Here, for example, you can see the OC3FO dataset. Each schema contains CSV files with column headers. We can process by downloading Scoper's Python wizard and run it on some shell along with the schema folder path. The wizard also creates semantic embeddings of the elements using schema metadata and optionally also instance samples. Afterwards, the linkability assessor computes PCA-based autoencoders throughout the full range of explained variants, ranging from 1 to 0, which is the core parameter for users to reduce schemas. We also compute the correlation between the autoencoder's predictions. And finally, one can specify from 3 semantic matching methods like LSH, along with some cardinality. We upload the generated CSV files and can see the entire pulley store as a graph with the 4 colored schemas. Note that the blue subgraph is the irrelevant Formula 1 schema and also the largest one. We can explore the pulley store by zooming in and out and drag and drop the nodes or hide entire schemas if needed. We can also look into the metadata details by clicking on a node. In order to reduce the schemas, we can gradually decrease the global variance parameter and see that certain tables and attributes become linkable among the autoencoders at lower model variance. For the related schemas, we see that the linkable elements on customers and products pop up, whereas the Formula 1 schema is entirely reduced. For example, we can see that product code is assigned linkable, color-coded with a tiny circle from the related yellow and green schema. The user can also disable the linkability predictions of entire schemas to explore the linkable subsets in particular schema contexts, like the green one here. If we double-click on a node, we see linkages between schemas, color-coded by similarity strength. Those can also be filtered using the similarity threshold. Finally, we can also show the pairwise correlation between the predicted linkability labels of the schemas. That we also provide as PNG plots over the full variance range to the user. They can be used as a statistical mean to prioritize highly correlated scheme pairs for matching over less correlated ones. With Scoper, we can significantly reduce the complexity of matching multiple schemas, considering the alternative of using their raw schema size.